Hello and welcome to Ashford.com. You are watching an interesting video on sleep switch. As we age, we lose cells in an area of the brain that allows us to sleep. Please read this disclaimer carefully. While scientists are aware that many older people struggle to get a good night's rest, the underlying cause of their insomnia and sleep disruption is largely unknown. Now, a new study suggests it may be because as we age, we lose cells in an area of the brain that allows us to nod off. Researchers have found that as we age, we lose cells in an area of the brain that allows us to sleep, providing clues as to why older adults experience insomnia. With his colleagues, neuroscientist Andrew Lim, assistant professor of neurology at Sunnybrook Health Sciences Centre in the University of Toronto, show for the first time that the amount of neurons in the sleep switch area of the brain, whose loss in rats leads to sleep disruption, is substantially diminished in the brains of older humans. They report their findings in the journal Brain. In many older people with insomnia and other patterns of sleep disruption, the underlying cause is unknown. We provide evidence that loss of neurons in a particular region of the brain that controls sleep may be an important contributor to insomnia in many older individuals, says Professor Lim. He and his co-researchers hope their discovery will lead to new treatments for insomnia and sleep disruption in older adults and help to improve their quality of life. Also, says Professor Lim, given recent evidence that sleep disruption may predispose to or trigger Alzheimer's disease, perhaps treatments based on the findings may even prevent or slow the disease. Co-author Clifford B. Saper, James Jackson Putnam Professor of Neurology at Harvard Medical School, Boston, MA, says compared with our 20s, by the time we reach our 70s, on average we get around an hour less sleep per night. Sleep loss and sleep fragmentation is associated with a number of health issues, including cognitive dysfunction, increased blood pressure and vascular disease, and a tendency to develop type 2 diabetes. It now appears that loss of these neurons may be contributing to these various disorders as people age. It was nearly 20 years ago when Professor Saper led research that found the sleep switch in the hypothalamus of rats. His lab discovered this inhibitory group of brain cells, known as the ventrolateral preoptic nucleus, was responsible for turning off the brain's arousal systems, allowing the animals to drop off to sleep. They found when the neurons were lost, the rats experienced profound insomnia, their sleep time was cut by 50%, and any sleep they did manage to get was fragmented and disrupted. The human brain has a similar group of cells known as the intermediate nucleus, also located in the hypothalamus, and it shows the same inhibitory neurotransmitters as in rats. The researchers wondered if it might behave in the same way in controlling sleep. So they looked at data from a long-term study of aging and dementia, where participants had volunteered to donate their brains to research when they died. That study, known as the Rush Memory and Aging Project, began following around 1,000 healthy 65-year-olds in 1997. Since 2005, some of the participants have been monitoring their activity every 2 years for about a week to 10 days by wearing actigraphic recorders on their wrists. The waterproof devices monitor all movements, large and small, in intervals of 15 seconds. Professor Lim says they had used these before in their research and found absence of movement for 5 minutes or longer correlated with sleep intervals. By comparing what they found in the brain autopsies of 45 of the participants who died at around 89 years of age with actigraph readings from the years leading up to when they died, the researchers found links between the number of neurons in the sleep switch area and the amount of sleep disruption, as Professor Saper explains. We found that in the older patients who did not have Alzheimer's disease, the number of ventrolateral preoptic neurons correlated inversely with the amount of sleep fragmentation. The fewer the neurons, the more fragmented the sleep became. They found the participants whose sleep switch contained more than 6,000 neurons spent at least 50% of their sleep time in non-disrupted sleep. but participants with fewer than 3,000 neurons in this brain area only enjoyed non-disrupted sleep for less than 40% of their sleep time. Notes and references. Thank you for watching this interesting video. This channel offers motivational, inspirational, valuable and informative videos to soothe, cleanse and inspire your health, mind, body and spirit. Subscribe this channel to find lot of interesting videos on wide range of topics here. Stay tuned and keep watching.